Welcome to the deep dive. Today, we're actually pulling back from, the constant stream of AI software news.
Yeah, there's always something new on that front.
Exactly. We're going deeper, looking at something, well, much more physical. We're talking concrete copper, the sheer energy that's actually fueling this AI revolution.
The foundational layer, really.
Right. We've been looking at reports, essays, mostly from late 2025, that really document this shift. It's where AI stops being just like code and ideas.
And becomes infrastructure, steel, power lines, massive buildings. It's tangible.
It really is.
And maybe we should start with the scale, because honestly, the numbers are hard to really wrap your head around.
Please do. Set the stage for us.
Okay, so what started, years ago as pure research algorithms models, it's a full-blown global industrial boom, coordinated.
Industrial boom. It sounds big.
It is. Think dedicated chip manufacturing lines, huge cooling systems needing gigawatts of power, entirely new energy grids built just for AI.
Just for AI.
What?
Wow.
Yeah. And when analysts started adding up the planned spending, the capital expenditure, they landed on this term, the AI compute economy.
Okay.
The estimated investment flowing right now into this. It's expected to be over $1 trillion. North of $1 trillion. And that's capital committed, flowing into actual physical assets, building servers, power infrastructure.
Okay, $1 trillion.
Yeah.
That changes everything, doesn't it? That's not R&D budgets anymore. That's industrial policy, national level stuff.
Precisely. And that leads to our mission today, right? We want to unpack the vision that's driving this insane level of spending.
Yeah, what's the big idea behind it all?
It's this belief shared by the key architects that we need to build AI infrastructure on a scale, well, comparable to huge historical shifts.
Like what? What are we comparing this to?
Think 19th century railroads connecting continents, or the 20th century power grid electrification, or maybe the laying of the first internet backbone cables, that kind of foundational build-out.
Okay, so truly transformative infrastructure. And who are the main players, the architects, shaping this?
We're focusing on three key figures today: Sam Altman at OpenAI, Jensen Huang at Nvidia, and Elon Musk with xAI.
The big three driving this.
Exactly. And if you look for, the philosophical justification for spending $1 trillion, it really comes from Sam Altman. He has this core concept he talks about.
Which is?
The pursuit of abundant intelligence.
Abundant intelligence.
Yeah, and it's not just a catchy phrase. It's framed as an economic necessity. The idea is if you want AI for tutoring, for medical advice, coding, whatever, to be available to everyone.
Like a utility.
Exactly like a utility, or even a basic right.
Right.
Then it needs physical scale, just like steel drove the last industrial age or electricity powered the one before. Intelligence needs infrastructure, mass-scale infrastructure.
Got it. So the ambition is huge, and the infrastructure has to match. Let's unpack that ambition then. Starting with Sam Altman at OpenAI, you called him the architect of abundance, Altman's vision. It feels different. He immediately takes AI out of this, niche tech category.
He does. He reframes it. It's not just fancy software for corporations.
Right. He talks about it like a universal utility, almost like a human right.
That philosophical stance is key. And what's really fascinating is how quickly that idea, AI, as a public good, translated into these massive concrete infrastructure deals.
So the philosophy directly drove the spending.
Absolutely. If you genuinely believe AI can give every kid a personal tutor or speed up finding cures for diseases or just, eliminate drudgery, then you feel you have to scale it globally.
A moral imperative, almost.
Kind of, yeah. But delivering that right to billions of people, that needs physical stuff. Data centers handling unbelievable amounts of data, cooling systems, gigawatts of power. It starts looking like those national infrastructure projects we mentioned.
And his answer for how to build all that isn't just OpenAI footing the bill, is it?
No way. They couldn't possibly. His approach is what the sources call the $1 trillion partnership blitz.
Okay, partnership blitz. What does that actually mean?
It means he's not just writing checks. He's building this dense network. It involves suppliers, builders, financiers, all interconnected. It's designed to be financially self-reinforcing.
Like a flywheel.
Exactly, an AI flywheel. The goal is to build faster than traditional VC funding or corporate budgets would ever allow. And we saw the proof in late 2025 with some huge deals announced.
Let's get into those deals. They show the architecture.
They really do. The structure is, well, it's either genius or madness, depending on your perspective. They're locking in compute and and energy using everything. Direct investment, equity swaps, huge contracts guaranteeing they'll use the capacity later.
Give us an example.
The big one is the $300 billion partnership with Oracle.
$300 billion. With Oracle.
Yeah, and it's not just like renting some servers in the Oracle cloud. This is funding dedicated construction, AI-optimized data centers built specifically for OpenAI across the U.S.
So Oracle gets a massive guaranteed customer.
Right, validates their whole push into AI hyperscale compute.
And OpenAI gets the physical space, the custom cooling, everything they need built to spec.
Exactly. It secures the physical foundation.
Now, a lot of the talk is always about Nvidia, but Altman's not putting all his eggs in one basket, is he?
No, and that's strategically critical. The diversification piece is huge. They announced a multi-billion-dollar chip deal with AMD.
Okay, AMD, a serious competitor.
And importantly, the deal reportedly included clauses that could make OpenAI a significant shareholder in AMD down the line.
Ah, so aligning incentives even further. Why is that diversification so important for Altman's vision?
Well, think about it. If you're trying to build a universal utility, something as fundamental as electricity, you can't be beholden to a single supplier, especially one whose chips are in such high demand and, frankly, are very expensive.
Creates too much risk. Bottlenecks.
Precisely. The AMD deal gives them a solid, competitive second source, especially for inference.
Inference. Explain that quickly.
Right. So you have training the big AI models, which takes massive compute power in one go. That's often NVIDIA's top-end stuff. But then you have using the model's inference, millions of people asking questions, generating images. That's huge volume, but needs slightly different, maybe more cost-effective chips. AMD is targeting that space aggressively.
Got it. Training versus using. But even with AMD in the mix, the NVIDIA relationship is still massive, right?
Oh, absolutely colossal, fundamental. Sources estimate around a $100 billion deal just for ongoing access to NVIDIA's latest and greatest GPU clusters for that heavy training.
Okay, so $300 with Oracle, multi-billions with AMD, $100 with NVIDIA. The numbers are adding up.
And there's another piece for the using part, the inference scaling.
Yeah.
The $22.4 billion expansion with CoreWeave.
CoreWeave, what's their role?
They specialize in a specific niche. Think about millions of users hitting ChatGPT or DALL-E all at once. The demand spikes like crazy.
Right, unpredictable peaks.
Exactly. CoreWeave provides high-density GPU capacity that can be spun up and down really quickly, really efficiently. They handle that dynamic scaling, that volatility of usage, when the AI becomes truly universal.
So you've got Oracle for the base build, NVIDIA for the high-end training, AMD for diversification and maybe inference, CoreWeave for dynamic scaling. It's a complex web.
It is. And when you pull all those contracts and the projected spending together, that's how analysts get to that $1 trillion figure. It's the total capital flowing through this ecosystem OpenAI is anchoring.
Which brings us to the money question. How on earth is this sustainable? How is it financed?
Right. That's where this economics of circular capital, the AI flywheel idea comes in. It's crucial.
Explain the flywheel. How does it work?
Okay, step one. OpenAI raises huge amounts of money selling equity, maybe debt, billions.
Okay.
Step two, they immediately turn that cash into purchase orders for physical compute. Chips from NVIDIA and AMD, data center space from Oracle and CoreWeave.
Plowing the money straight into hardware and infrastructure.
Instantly. And this massive, sudden injection of capital does something interesting.
What's that?
It dramatically boosts the value of the suppliers and partners. Their stocks surge, their revenue forecasts go through the roof because OpenAI is such a huge customer.
And we actually saw this happen.
Oh yeah, the sources have hard numbers. AMD stock jumped almost 40% right after their deal was announced. NVIDIA, already huge, but its market cap blew past $4.5 trillion. Oracle's data center division, record growth, largely driven by the expected AI build-out pipeline.
Wow. So OpenAI's spending directly inflates the value of its partners.
Which makes those partners look even more attractive to other investors, attracting more capital into the whole ecosystem.
Which in turn makes it easier for OpenAI to raise the next round of funding to buy more compute.
You got it. That's the flywheel. Spending creates value, which attracts more spending. It's a self-reinforcing loop designed to accelerate the whole process.
Okay, that's clever. But it also sounds a bit precarious. Is it built on solid ground?
That's the critical question, isn't it? You mentioned madness earlier. This entire infrastructure race, this trillion-dollar bet, it's financed almost entirely on the expectation of future profits. Massive exponential profits.
Based on the assumption that abundant intelligence will unlock trillions in economic value someday.
Precisely. But the current financials, they're stark. At the time of these reports, late 2025, OpenAI was pulling in maybe $12–13 billion in annual revenue.
Which sounds like a lot.
It is, but their costs running the models, R&D, and crucially, these massive infrastructure investments meant they were estimated to be losing around $5 billion a year.
Wait, losing $5 billion annually?
Yeah.
While orchestrating a trillion-dollar ecosystem spend. How does that math work? Why are investors still pouring money in?
It's the ultimate high-stakes gamble. It's a bet on future market dominance and the idea that the cost of intelligence will eventually plummet once the infrastructure is built.
Conquer scarcity now, own the market later.
That's the logic. Critics absolutely call it a dot-com era reflex. Remember companies burning cash to grab eyeballs, promising profits later?
I do. A lot of them didn't make it.
True. But the bulls argue this time is different. The demand for the product intelligence itself seems almost limitless, unlike, say, demand for pet food delivery in 1999.
So insatiable demand might justify the burn rate.
That's the bet. A massive, massive bet on AI's deflationary power. But it absolutely depends on hitting that abundance goal.
And to hit that goal, to justify the spending, Altman needs this infrastructure built at an incredible speed, which leads to this concept of the gigawatt cadence.
Yeah, that phrase really captures the operational intensity. It's not just a target, it's a manufacturing philosophy applied to construction.
What's the actual goal?
Altman's stated aim, build 1 gigawatt of AI infrastructure every week.
1 gigawatt. Every week. What does a gigawatt even power?
A gigawatt is roughly the power needed for a medium-sized city, or, several massive hyperscale data centers.
So building the equivalent of a city's power demand worth of AI data centers weekly.
That's the ambition. And you can't do that with traditional construction methods. It requires radical standardization, modular designs, military-grade logistics, treating data center deployment like cranking widgets off an assembly line.
Which must be why he's pushing towards this vertical integration model, this AI Inc. idea. You can't wait on others at that speed.
Exactly. The AI Inc. thesis is simple. Chips, AI models, data centers, even the energy supply they have to be treated as a single integrated system.
Because any delay in one part breaks the whole cadence.
Precisely. Waiting for chips, waiting for grid hookups, that kills the velocity. By integrating vertically, or at least through extremely tight partnerships, you align everything. Hardware development gets synced with model design.
And that also explains the push for diversification with AMD and maybe even designing chips in-house eventually. It's about control.
It's entirely about control over the cadence. If you depend solely on NVIDIA's roadmap and production schedule, you've outsourced your destiny. Altman wants to control the pace.
Okay, so integrated system, breakneck speed. Where is all this happening? Geographically. The reports mention a focus on the United States for the core build-out.
Yes. The primary physical infrastructure is being prioritized domestically in the U.S.
Why the U.S. focus?
Several reasons. Mitigating geopolitical risks, especially dependence on Asian manufacturing, appealing to U.S. national security interests, which helps with things like permits and policy, and seeking, frankly, a more predictable regulatory environment, at least initially.
But the money needed, you said $1 trillion. That can't all come from U.S. investors, can it?
No way. The scale is just too vast. So while the build is U.S.-centric, the capital mobilization is global. Altman has been on a world tour, essentially.
According to who?
Sovereign wealth funds. Think massive pools of government capital from the UAE, Saudi Arabia, Japan, Singapore. He needs trillions, and that's where you find that kind of money looking for long-term bets.
So U.S. infrastructure funded by global capital, aiming for a universal utility. It's a fascinating, complex picture.
A synthesis of, utopian goals and sheer industrial force, all focused on breaking the compute and energy bottleneck. Which leads us perfectly to the guy building the actual engines for this revolution.
Right, Jensen Huang at Nvidia. His perspective seems totally different. Not software, not philosophy, but pure industrial engineering.
That's exactly his frame. He sees this whole thing as a manufacturing revolution. He's the engineer making the machines work.
And his core idea is reframing the data center itself, right?
Completely. He's adamant, stop calling it a server farm. It's not a collection of general-purpose computers anymore.
What is it then?
He says it's one colossal computer.
An AI factory.
An AI factory. I like that.
Its single purpose is manufacturing intelligence. Instead of cars or phones, it outputs tokens.
Tokens being the basic units of AI. Words, pixels, code snippets.
Exactly. Words, images, commands for robots, protein structures, Whatever the AI generates, that's the factory's product.
And if the data center is the factory...
Then Huang is crystal clear. The GPU is the new steam engine.
Okay, explain that analogy. It's about the core power unit driving the transformation. The steam engine took thermal energy and created mechanical power, replacing muscle. The GPU takes electrical energy and performs massively parallel computation, essentially creating cognitive output, or intelligence.
Replacing slow, sequential processing.
Right. And NVIDIA's entire focus is on optimizing that conversion, full stack. From the silicon architecture, like their new Blackwell chips, up through the networking, the software, everything is geared towards efficiency. They aim for something like a 10x to 20x improvement in cost efficiency with each generation.
A huge leap.
That's how they argue they can make manufacturing trillions of tokens economically feasible at the scale Altman and others demand.
And that demand, Huang calls it the hyper-exponential phase.
Yeah, hyper-exponential. It sounds like marketing hype, but the logic holds up.
Why hyper?
Because it's compounding. First, the AI models themselves are getting smarter, which requires exponentially more compute just to train them. Frontier models are doubling in complexity like every 6 months now.
That's one exponential curve.
But then, as the models get more useful, more people and industries start using them. For everything. Robotics, drug discovery, and multimodal search that understands images and sound. That multiplies the demand for inference, for deployment.
So bigger models, A&D, wider usage, two curves multiplying each other.
Exactly. That's the hyper-exponential demand. And it leads to mind-blowing spending forecasts. Global spending just on AI chips, projected to hit $1 trillion annually by 2030.
$1 trillion a year just on chips.
Yeah. And total investment in dedicated AI infrastructure, expected to reach $2 trillion overall by just 2026. Remember, this market barely existed 5 years ago.
It's incredible growth.
Yeah.
Now, central to meeting that demand and NVIDIA hitting those numbers is that massive deal with OpenAI you mentioned earlier.
The Vera Rubin platform.
Right.
Named after the astronomer who discovered dark matter, fittingly.
Why is that deal so significant, beyond the price tag?
Because it's not just OpenAI buying a ton of NVIDIA GPUs. It's described as a deep collaborative engineering project.
Building something new together.
Essentially, yes. This reported $100 billion build-out involves deploying infrastructure capable of handling about 10 gigawatts of power.
10 gigawatts, that's enormous.
It's enough to support an estimated 4 to 5 million of NVIDIA's most advanced GPUs working in concert. If they pull it off, sources say it could be the largest single AI infrastructure project ever built.
What does that scale mean, practically?
It means compute becomes a strategic national asset, like an aircraft carrier fleet or the power grid itself. It confirms compute as the new currency of global power and influence.
And all that compute, all those GPUs, they need electricity. A staggering amount. This brings us back to the energy problem. Huang has a specific take on this, right?
She does. It's almost philosophical, bordering on mystical sometimes. He says, AI is the transformation of energy into intelligence.
Okay.
Unpack that. He reframes energy use. It's not a regrettable side effect. It's the fundamental input to the AI factory, just like raw materials go into a car factory. The challenge isn't that AI uses energy, but how efficiently you can deliver that energy and convert it.
So efficiency is key. But he acknowledges energy is the ultimate limit.
Absolutely. He's very clear. Energy availability, not algorithms, is the final bottleneck for progress.
So if energy is the limiter, what's the NVIDIA solution? How do they plan to overcome it?
It's pragmatic, really. Two main parts. First, energy sources. He pushes for an all-energy approach.
Meaning?
Meaning, use everything that works and is reliable. Nuclear, natural gas, solar, wind, fusion when it arrives. Don't be picky, just get the power generated. And crucially, co-locate the data centers right next to the power plants.
Cut down on grid transmission losses and strain. Build the AI factory next to the power station.
Exactly, minimize the distance. The second part is the technology itself. He argues accelerated computing using GPUs is inherently energy-saving.
Wait, how? GPUs are power-hungry beasts, aren't they?
Per second, yes. But they finish the job so much faster than traditional CPUs for AI tasks. Think hours instead of days or weeks. So the total energy consumed for the entire task is dramatically lower.
It's about energy per result, not energy per second. Faster completion means less total power used overall.
Precisely. It's a crucial distinction, and their engineering reflects this. They're developing advanced liquid cooling.
Liquid cooling. like in high-end gaming PCs.
On a whole different scale. We're talking systems that allow server racks, or nodes, to handle up to 120 kilowatts of heat each.
120 kilowatts per rack. That's immense heat.
It is, but that density allows you to pack way more GPUs into the same physical space. Better space efficiency, better material efficiency. It all feeds back into making that gigawatt cadence feasible.
So Altman builds alliances for a utility. Huang enables the whole ecosystem. The sources call his model collaborative capitalism. That sounds different from aiming for a monopoly.
It is different. NVIDIA isn't trying to own the final AI application like the search engine or the chatbot. They want to own the foundational tools that everyone else uses to build those applications.
Sell the picks and shovels during the gold rush.
A very advanced set of picks and shovels, yes. And they actually invest directly in their partners OpenAI, Musk's XAI CoreWeave to make sure the ecosystem using their tools grows rapidly.
So they help create their own customer success.
It's a virtuous cycle for them. A bigger ecosystem means more demand for NVIDIA hardware and software. Self-serving, but collaborative.
And it's not just the chips they're selling, is it? It's more comprehensive.
Oh, absolutely. Huang is famous for saying, we don't sell chips, we sell an ecosystem. They provide the entire compute stack.
Meaning?
GPUs, yes, but also their own CPUs, Grace, advanced networking tech, InfiniBand Ethernet, the crucial CUDA software platform that everyone builds on, and even complete data center blueprints, reference designs.
So a company or even a country could basically buy the NVIDIA starter kit for building their own AI industry.
That's the idea. Standardized, high-performance building blocks. It allows partners and nations to get up and running quickly, building their own sovereign AI capabilities, but all based on the NVIDIA platform.
Before we move to Musk, there's a really important point Huang makes about the economy, specifically jobs. It runs counter to the usual AI will take all the jobs fear.
Yes, this is maybe the most grounded and optimistic part of his narrative. He argues passionately that this AI infrastructure race won't be won by coders alone. It will be won by the trades.
The trades. You mean electricians, plumbers?
Exactly. Electricians, pipe fitters, welders, HVAC technicians, concrete workers, general construction crews. Building these massive AI factories requires millions of skilled manual workers.
So the physical build-out itself is a huge job creator.
Massive. Governments and companies are projected to spend something like $7 trillion globally by 2030 just on building the physical layer. Power plants, transmission lines, cooling infrastructure, the data center buildings themselves.
$7 trillion. That's a huge direct stimulus into traditional industries.
It's a potential reindustrialization driver. Huang estimates just one of these 1 gigawatt AI factories, the kind Altman and Musk are planning, could generate $60 billion in annual economic output and support tens of thousands of jobs.
Wow. Manufacturing, construction, logistics, ongoing maintenance.
Right. It suggests a future economy split.
Right.
You'll have factories making the hardware like TSMC in Taiwan, and then these new AI factories manufacturing the intelligence, a whole new industrial layer.
Okay, so we have Altman, the visionary architect of abundance through alliances. We have Huang, the master industrial engineer providing the core machinery and ecosystem. Now let's turn to the third key figure, known for sheer speed and ambition, Elon Musk. He enters this AI infrastructure race with XAI in his approach. It feels different again, rooted in, what, science fiction almost.
Yeah.
And that relentless execution we see at SpaceX and Tesla.
Absolutely. His core vision frames AI very differently. It's not primarily about social utility like Altman or industrial process like Huang. For Musk, AI is the cosmic scale problem solver.
Cosmic scale, what does he mean by that?
He talks about using AI to help humanity fundamentally understand the universe, tackle the biggest questions in physics, consciousness, the nature of reality, AI as the ultimate scientific instrument.
So a tool for profound discovery.
Right. And to build that tool fast enough, his absolute top priority is speed. Velocity, execution speed, deployment speed, iteration speed. That's his main weapon, his competitive moat.
And he achieves that speed by applying the playbook from his other ventures, right?
Yeah.
The gigafactory of compute model.
That's the perfect term for it. He's taking the lessons learned from building huge battery factories for Tesla and mass-producing satellites for Starlink.
Which are all about self-reliance, vertical integration, just crushing traditional timelines.
Exactly. And applying that to building AI supercomputers. His main project at XAI is called Colossus 2.
Colossus. Apt name. How big is it?
It's scaling incredibly fast. The target mentioned in sources was 780,000 GPUs, but the really wild part is the stated goal: double its capacity every 2 to 3 months.
Doubling every few months. That's insane scaling.
It is, and his longer-term ambition is just staggering. He's talked about needing 50 million H100 equivalent GPUs within 5 years.
50 million. That's an order of magnitude beyond what others are publicly targeting, isn't it?
Way beyond. Whether it's achievable is another question, but it shows the sheer scale of his ambition. And the velocity is real.
You have examples of this speed.
There's a specific anecdote in the source material that highlights it. Musk's team reportedly deployed 100,000 Nvidia GPUs in just 122 days.
100,000 GPUs in about 4 months, from delivery to operational.
Yeah. Think about what that involves. Receiving them, racking them, connecting power, networking, cooling, software provisioning, all at massive scale.
How does that compare to, say, traditional cloud providers?
The sources suggest for a traditional hyperscaler, just getting the permits, the land, the power agreements, and the chip allocation often takes 6 to 9 months before they even start racking servers. Musk's team achieved deployment in a third of that time. It's near military tempo.
How? What's the secret to bypassing the usual bottlenecks, permits, supply chains that seem to slow down others, even Altman?
2 words: control and capital. Where Altman builds alliances, Musk builds in-house capability and leverages his existing industrial base.
Using Tesla and SpaceX know-how.
Exactly. Tesla Energy gives him deep expertise in large-scale power systems, batteries, grid interaction. SpaceX gives him mastery of complex logistics and high-volume manufacturing. He minimizes dependencies.
So for that huge Memphis gigacluster they're planning.
Right, the one needing over 1 GW of power from the Tennessee Valley Authority, TVA. His teams are likely managing the power infrastructure planning, the cooling systems, everything, in parallel with the building construction and GPU deployment. Pre-investing, pre-planning, forcing the pace.
So his view on energy is different too. Altman sees a bottleneck needing alliances. Huang sees an industrial input needing efficiency. Musk sees it as
a logistical challenge. Pure and simple. Something to be conquered with engineering and relentless execution. He calls it feeding the beast.
Feed the beast. Classic Musk.
It reflects his methodology. Self-reliant, execution-obsessed. Build it yourself, control the process. He builds the hardware assembly lines, the data centers, prioritizes control above all else. There's a quote attributed to him: "If you don't own the stack, you don't own the destiny."
Own the stack, own the destiny. That explains the drive for vertical integration and speed.
It's what enables that signature hyperacceleration. He avoids the friction you inevitably get in large, multi-party alliances.
Okay, so this gives us a really clear picture of the 3 main players. Can you quickly summarize the contrast? How does this triangular race look?
Yeah, it's a useful comparison you have.
Focus on software and superintelligence. His goal is societal. Abundance for humanity, achieved primarily through complex financial and industrial alliances.
Okay.
Along Nvidia.
Yeah.
Focus on hardware and AI factories. His goal is also societal, but through industry. Prosperity via industrial output, achieved through ecosystem enablement and full-stack efficiency.
Got it. And Musk.
Musk SAI. Focus on execution and self-reliance. His goal is more cosmic. Understanding the universe, achieved through breakneck speed and proprietary control.
Software, hardware, execution. Abundance, prosperity, understanding. All needing trillions in infrastructure.
Exactly. 3 distinct strategic approaches, all converging on building this new foundation for the 21st century.
All right, let's try to synthesize all this. These 3 massive efforts. The sources say they form a kind of dual engine for the AI economy. What does that mean?
It means they're deeply interconnected, almost symbiotic. You can think of it like this. Altman's grand vision for superintelligence needs Huang's superclusters to run on.
The software needs the hardware.
Right. And the whole enterprise is fueled by the massive financial expectations we talked about. Musk then injects this element of hyperacceleration, constantly pushing the speed limit for everyone else.
So they're competing but also enabling each other in a way.
Absolutely. They all fundamentally agree on the core premise. AI infrastructure is the new industrial foundation. It requires trillions in capital, requires unprecedented amounts of energy. That's the common ground.
But their methods are where they diverge sharply, right?
Totally. Altman's path is decentralized alliances, spreading the risk, trying to ensure broad access, building a global network. Huang's is vertically integrated efficiency, selling the standardized tools, the full stack, to everyone, maximizing adoption of his platform.
And Musk.
Musk is all about self-owned control and velocity. Speed above all, keep critical capabilities in-house, minimize dependencies.
And this divergence, this friction between strategies, that's where innovation happens, and maybe risk.
Exactly. It drives faster development, alternative approaches, but it also creates market volatility, supply chain tensions, and intense competition.
Now, all this massive scaling, regardless of the strategy, bumps up against one huge, unavoidable wall.
Huh.
Energy, the energy bottleneck. Every leader acknowledges this is the ultimate limit.
It's the critical physical constraint. And the numbers are genuinely alarming for existing infrastructure. These hyperscale AI data centers, they need huge plots of land, consume incredible amounts of water for cooling.
And the power draw.
Is immense. Some analysts are projecting that by 2030, AI computation globally could demand 10% of total current U.S. electricity consumption.
10% just for AI. How do you even visualize that?
Think about the entire residential electricity usage of California and Texas combined. That's roughly the scale of new demand AI could place on the grid within a decade.
That's staggering. Are we already seeing the impact?
We are. The financial repercussions are hitting utilities now. In areas with heavy data center concentration parts of the U.S. South, the mid-Atlantic local electricity prices near these facilities have reportedly spiked by as much as 267%.
Whoa, 267%. That's not market fluctuation. That's a system under extreme stress.
It is. Utilities are scrambling to upgrade transmission lines, build new generation. It costs billions, and it raises serious questions about whether AI is crowding out power needed for other industries or even just homes.
So if the basic input cost electricity is skyrocketing like that, how does the economic model of abundant near-zero cost intelligence hold up?
That's the trillion-dollar question, isn't it? The whole model relies on the efficiency gains from chips like Nvidia's Blackwell outpacing the rising cost of power.
If efficiency doubles but power costs triple,
then the path to cheap, abundant AI gets much, much harder economically. It pushes even harder towards specialized solutions, data centers built right next to nuclear plants, or running on dedicated microreactors, which of course further concentrates power and control.
and these very real infrastructure limits, power, water, land, permits, they directly feed into geopolitical risks, don't they? Both Altman and Huang seem worried.
They're explicitly warning about it. They say the U.S. lead in AI is not wide and closing fast.
And the main obstacle isn't lack of ideas.
No, it's the physical world stuff.
Yeah.
Slow permitting for new power plants and data centers. Regulatory hurdles. Energy constraints. Meanwhile, other nations might be moving faster on the physical build-out.
And compute capacity itself is becoming a strategic asset.
It's the new oil, as the saying goes. Whichever nations control the majority of AI compute power will have disproportionate economic leverage and, frankly, national security advantages.
Jensen Huang points to a specific geographical vulnerability here too, doesn't he?
He does. He consistently highlights Taiwan, specifically the chip fabs at TSMC and the advanced packaging and assembly at places like Foxconn, as the absolute core of the AI hardware manufacturing ecosystem.
So the world's most advanced, most critical industrial supply chain runs through one tiny, geopolitically sensitive island.
Precisely. So you have Altman building this global network for capital, pulling money from the Middle East and Asia. But Huang's global network for hardware remains heavily reliant on Taiwanese manufacturing excellence. It's a major source of tension and risk.
Okay, so we're left with this intense duality running through all the sources, this incredible promise versus some very real, very large perils. What's the ultimate utopian vision here? Why take these risks?
Altman, especially, paints a picture of fundamental positive transformation. AI democratizing creativity, automating drudgery, curing diseases, maybe even solving climate change, leading to true economic abundance.
A post-scarcity world.
That's the dream. And he argues the biggest risk, the greatest moral failure, would be not building it. Letting fear of the costs or complexities stop us from achieving those benefits for humanity.
But the perils are right here, right now. Economic distortions from speculative bubbles.
That .com reflex again.
Antitrust concerns about the sheer market power being concentrated in OpenAI, Nvidia, maybe xAI.
Definitely.
Plus, huge questions about data privacy, data sovereignty as these systems become global. It complicates the expansion.
It's the classic tension of any major technological shift, right?
Yeah.
The potential upside is almost unimaginable, but the immediate path is fraught with physical limits, economic risks, and complex governance challenges. The sheer scale of the bet, trillions of dollars, means the consequences, good or bad, will affect everyone. National security, jobs, the economy, everything.
Wow. Okay, that was quite the deep dive into the engine room of the AI revolution.
Yeah.
If we pull back for a final thought, the big takeaway seems to be this isn't just about code anymore. It's a full-scale industrial build-out, creating what the sources call a highway for intelligence.
That's a great analogy. It really captures the scale. Think about it. The 20th century was about industrializing muscle power, steam, electricity. The 21st is about industrializing mind via compute power.
Building the infrastructure for thought, almost.
And if this huge bet pays off, if energy and compute do become abundant and cheap, AI could trigger a massive economic deflationary era.
Deflationary, meaning prices fall.
Potentially, yeah.
Yeah.
An era where productivity gains from AI consistently outpace the costs of production. It could fundamentally reshape capitalism, which is traditionally built on scarcity. Abundance changes the rules.
Achieving that goal of abundance through sheer industrial scale.
Which brings us to our final provocative thought for you, the listener, to mull over. We spent this whole time talking about the race to make intelligence cheap, ubiquitous, abundant.
Right. The goal is to make AI intelligence no longer scarce.
So the question is, if or when artificial intelligence does become cheap and universally available, if intelligence itself is no longer a scarce resource, what uniquely human resource suddenly becomes the scarcest and therefore potentially the most valuable commodity?
So if AI can do the thinking, the analysis, the problem solving, what's left for us that's truly valuable?
The sources we looked at suggest the answer isn't technical skill or financial wizardry, things AI might replicate or exceed.
So what is it then?
The new bottleneck, the truly scarce human resource, might become creative and ethical leadership.
Leadership, explain that.
Well, when you have nearly infinite, nearly free compute power, capable of solving almost any defined problem, the crucial skill becomes defining which problems are worth solving, asking the right questions, determining the purpose behind deploying all that power.
So judgment, wisdom, setting the direction.
Yes, exactly. The ability to envision a desirable future, to make ethical choices about AI's application, to lead with creativity and empathy in a world saturated with artificial intellect. That might become the rarest and most valuable human contribution. Food for thought.